Okay, welcome back, grade 9 applied students. This is Unit 7, Lesson 7, where we're going to try and create a scatter plot of the data we collected in Lesson 6. So the first slide here is a review. Now some of this might not be a review because I had to teach this out of order because I switched the order because I thought we might be going back, but now I'm not so sure. Normally I would do Units 4, 5, and 6 before 7. So I'm going to suggest you pause this and maybe use Google. I'm just going to show you that the class note you have sort of looks like this. And you're filling these in with the correct answer. If you're not sure, maybe you can Google some of these. So I'm going to pause the video. I'm going to suggest you pause and then you kind of drag these to where they belong. You can use Google if you're not sure. Okay, we're back and we'll start taking these up. First off, I just want to make sure that I'm using a fine point pencil now. Okay, a graph that shows the relationship between two variables is points plotted on the Cartesian plane, for example, something like this. That's called a scatter plot. A value that can be changed is called, or change or vary is called a variable. The value that goes on this axis over here, the horizontal axis or the x-axis, that's in math called the independent variable. So independent down here. Dependent variable goes on the vertical axis. The pattern, so right now this looks sort of like a curve. That pattern that we find between two variables is called a relationship. Data which takes on certain values only, like quantities which are counted, is called discrete. So if I was going to count, let's say, the number of people that eventually will watch this video, hopefully that's a high number, it certainly can't be a half a person or a quarter of a person or a third of a person. It has to be whole values. So 1, 2, 3, 4, etc. Those are called discrete values. Continuous values are values that are measured. So let's say your height right now was 5'5", and let's say when you were born you were 20 centimeters. And then let's make this easy for me. Let's say right now you're 160 centimeters. So you will continuously grow from 20 to 160, i.e. you will hit all values between 20 and 160. You're not 20 and then all of a sudden instantaneously you jump to 30 at one point in time, and then you stay at 30 for a long period of time, and then all of a sudden you jump to 45 instantaneously. You continuously make that journey from there to there. So we call that a value that's measured. A scale, so we're going to have some marks on here. They're evenly spaced. I use a ruler and the scale will tell me what I was going up by. So if this was 4, then I was going up by 2s. And then I should put a label here telling someone what it is I'm plotting here, and we'll see that later on. And then we'd have a title across the top telling us what we are graphing. All right, so that would have been a review. I know it's new learning for you here now. All right, so what I need you to do now, coming over here, so if you have this sheet in front of you, this page here, 12 meters of fencing, 20 meters of fencing, that's referring to this chart and this chart. See if I can highlight that. This one and this one. So those are the two you would be filling in. And the values you're going to fill it in with are these values right here. So I'm going to pause as a reminder for you to pause. So you can take the values that are here and record them over here so that later on, so we're going to get you to record them there, so that later on you can create the graph. So I'm going to pause and let you do that now. All right, back to our discussion. So those are the values that you would have recorded on your chart. And now I'm going to create a graph. And notice here's the title. This is my label, width in meters, area in meters squared. This here, width, is my independent variable. Area is my dependent variable because it's on the vertical axis. Width is independent because it's on the horizontal axis. And now I have marked on a scale, and we can see I'm counting by ones, but I'm only labeling every other one. So my scale is indicating go up by 1 in this direction, and also it's indicating go up by 1 in this direction. And what you're going to do now is, let's look at what it's asking us to do. It's asking us to plot width versus area. And we've got 1, 2, 3, 4 columns here. The columns it wants are width versus area. This is for the 12 meters of fencing. And then we want to look at width versus area for the 20 meters. And that's going to go over there. So you're going to plot this. And now, to help you remember how to plot, so when width is 0, area is 0. So 0 in the left-right direction, and then 0 in the up-down direction. That would be that point. This is the point 1 and 5. So 1 over in the left-right direction, and then up to 5, which would be right there. And then 2 over in the left-right direction, up to 8. And then we would be 3 to 9, because I know we haven't practiced this. That's why I'm showing this to you. You have to do this in the correct order. It's independent is this value here, and dependent is that one. So 4 for the width and 8 for the area. So 4 and then 8. Independent first, left, right, dependent that way. Then we're looking at the point 5 and 5. So width of 5, we have an area of 5, and then we have a width of 6, and we have an area of 0. So that's the correct way to plot. So I'm going to suggest you pause, and I'm going to pause as a reminder for you so that you can follow that technique I showed you there, and you can plot all of this. And if you can print the note, you could just sort of be graphing that one. The first one you would graph here, and the second one is going to be graphed right there. If you can't print the notes, that's okay. You can sketch this on whatever kind of paper you have handy at home. Maybe an iPad as well. All right, so I'm going to pause so you can do that next graph. Okay, so we're back. And back to here. So if you plotted all of these points, you'll get this graph right here. If you want to check, you can always pause the video recording. All right, whenever you want. I can't force you to pause, but I just highlight this as a reminder to show you. You should. If you want to pause to make sure you are correct, you could do that now. So notice what's happening here. So we had talked about as we are moving this way, the width and the length were getting closer together. I do think I want to go back just so that we can come to the chart over here, because we had talked about that. Maybe it's bigger over here. So we had talked about the length and width are getting closer together. Closer together. Now they're 0 units apart. And now they're getting further apart. Further apart here. Further apart. So spacing 6 to 4 to 2 to 0 to 2 to 4 to 6. So initially in this area, or this range, the area is going up. And in this range, the area is going down. So as the length and width get closer to each other, the width goes up, and when they get further apart, sorry, the area goes up, and when they get further apart, the area goes down. Same thing is happening here. The area is going to go up here because the length and width are getting closer together, and then the area will drop in here because the length and width are getting further apart. So let's see what the graph is showing. So as the length and width get closer together, notice how the areas go up. We hit the maximum value when the length and width are equal to each other. And then as the length and width get further apart, the area drops. This point right here represents when the width is 0. When the width is 0, all of the rope went to the length, and 0 times 6 gave us an area of 0. Here the width is 6. And that makes the length 0, and 6 times 0 is 0. That's why we're getting an area of 0 there. And notice in this case, as the length and width get closer together, the area goes up. We hit the maximum value at 5 when the length and width are both 5. So this is 5. And at this point, the length and width are both 5. And then the area drops now because the length and width are getting further apart. And over here, the length and width are equal to each other. at 3. And then we could draw a curve. This is going to be very difficult for me to try and draw a curve through this. I think I'm going to pause and see if I can find a mouse. All right, so I found a mouse, but I'm not sure that I was any better at attempting to draw a curve. So that was my attempt at drawing a curve through there. And we can see we have a maximum value or a vertex right here when the length and width are 3. I didn't try to draw one over there because that was going to be too difficult. All right, so the next thing we're going to do is, coming back to your sheet, moving over here, I would like you to fill in these 2 columns. Highlight them different because these are area questions now, where we have 36 concrete pavers and 64. So if you were able to print out the notes, then you're just going to fill them in with these numbers from here. So I'm going to suggest you pause now and you take some time to fill those numbers in. All right, moving forward, presuming that you filled these numbers in. So again, looking, both of these graphs have a title. We have labels here telling us that the dependent variable on the vertical axis is perimeter, measured in meters. The independent variable is width in both cases, measured in meters, as it is on the horizontal axis. And in this case, skip counting by 3, and over here, skip counting by 4. So the scale is 3 here, and the scale is go up by 4 there. The scale in this one is go up by 4 for the independent variable and go up by 8 for the dependent variable. So what you're going to do now is you are going to, again, we want width and perimeter. This is independent, this is dependent, so again, this will be hard. Where's 1? Like 1 is a third of the way through. If this is 3, 1 is there. Where's 74? Maybe I need to put in some intermediate values now to help me out. So we're counting by 4, so this would be 68. This would be 76. So halfway in between these two would be 74. That's what I'm after. And it's about a third of the way in. So I'm going to put a dot right about there. And the next point I would be plotting would be 2 and 40. Well, 40 is right there, but now I'd be 2/3 of the way over because it's 2 out of 3. The next one is 3 and 30. So 3 is right on here, but now I've got to find 30. So that would be 28. And 30 would be halfway in between these two, so I would plot it right there. And then we're looking at 4 and 26. So 26 is halfway there, and 4 would just be a third of the way in, so we're looking somewhere right about there, a third of the way in, and at 26, somewhere around there. And the next one is 6 and 24. This is 6, and that's 24 right there. Then we're going to move over to 9. This one is 9. 9, and we're back to 26, which is right here. And then 12, all the way over to 12, and then up to 30, and 30 was right there. And then 18, over to 18 to 40. And then 36, which is way out there, all the way up to 74. So this graph looks a little bit different than this previous one, because the previous one, if we're going to jump back up to it, it actually is symmetric. If you put a line right down here, that's like a mirror, and these are symmetric. There are mirror reflections about that line. That is not happening with this graph here. So try and draw, maybe you can try and draw a curve through that one as well. So what I'm going to get you to do is you plot both of these on your paper. I had modeled how to do that here, and in some of this it is going to be guesstimating, and there's nothing wrong with guesstimating. So again, pausing as a reminder that you should pause, and then you should graph these. All right, so you were going to plot these values here on this grid here. And again, if you were able to print the notes out, you'd be plotting those two graphs here and then right over here. This is the 36 pavers, and this one is the 64 pavers right in this area. If you weren't able to print it out, it's not a problem. Just practice on any scrap paper you might have at home. All right, so this is what the graphs would look like. And notice how, I forgot to discuss that with you, so maybe we'll come back here to the chart. We did notice the previous lesson that as the width and length get closer together, which is happening all through here, the perimeter is dropping. And then when the width and length get further apart, which is happening in this area there, the perimeter starts to increase. So we should expect a minimum value in these ones, whereas we had a maximum value for the area. We're going to get a minimum perimeter. So notice the perimeter starts decreasing as the length and width get closer together. The length and width are equal right here. And then it starts to increase again. And then notice how the length and width are getting closer together. So the perimeter is decreasing right here. We hit our lowest perimeter right there when the length and width are equal to each other at 8. And then the perimeter starts increasing again because the length and width are getting further apart. And that's what we were seeing on the chart here. That's where they're equal. That's the lowest perimeter. This is where they're equal. And that's the lowest perimeter. So moving forward, let's see what's left on your sheet. So what are the dimensions of the rectangle that encloses the largest possible area? Let me just copy that. Okay, I was finally able to get those questions copied as from here. So what are the dimensions of the rectangle that encloses the largest area in the garden? And it says justify your response using both the chart and the graph. So using the chart, we can see it would be the highest point on the chart. And that occurs when the width is 3. So yes, maybe I'm going to insert a text box. So when the width is 3, we reach the vertex of the graph. And I'll just put in brackets, that's the highest point in the area of, and coming back over here just to remind you, the area there was 9. And now it says to justify using the chart. So if we went back to the chart, which is over here, you could see in the chart, visually, we can just see that's the highest area right there. And from the chart, highest area occurs when width and length are 3. And if this was a test, you would just highlight that and point that out. All right. And let's look at those questions. They were the same questions over here. I'm not going to type it out. I'm just going to show you that on the graph, we are hitting a vertex down here, and this time the vertex is the low point. So you'd note that in your solution. You would say visually from the graph, I might even highlight this for my teacher in a different color. We'll highlight that in red. Visually from my graph, we can see that the vertex, there is a minimum at the vertex, and that is occurring when the width is 6 and we have a perimeter, the smallest perimeter of 24. And then you'd go back to the chart, and I would recommend that you just highlight that. And then you could tell the teacher, from my chart, see the row that I've highlighted, you can see that the minimum perimeter is 24, occurring when the width and length are equal to each other. And then the other things you have on here are just some application questions for perimeter if you want to try those. And if you're stuck, there's only 2 of them. No, there are 4 of them there. I thought 2 of them were the same. So you can try those 4, and if you have questions, you can contact me, and I will give you a hint if need be. So thank you for watching our lesson on creating a scatter plot for the data that we had collected the previous day. Thanks for watching. Take care.